Thank you for trying to surf with me for the next couple of minutes. What I want to do with you is to examine the question, is it just a fashion that we say this is a once-in-a-century special time, as we heard in my predecessor's speech, or is there something fundamental behind it? I want to put beef to this bone. You see another interesting group of people, maybe you've recognized yourself in this family picture here, which I've projected. And you know, maybe you found yourself, maybe not. That's the Mozilla Foundation, who also came together in Berlin 2 years ago to finalize the first release of the Firefox operating system. It was intended as a browser operating system, but the really interesting thing is that they achieved as a community something which Nokia was obviously struggling. They built an operating system as a community. And they finalized it not in Silicon Valley, they finalized it in Berlin. So there are a couple of strange occurrences in this picture which you would not think as an obvious one right away. Number one, finalization in Berlin. It's a global community, it's not a company, and they do something which is really difficult. And why are they able to actually do this? What I want to do is to share with you in this argumentation why we do have a huge wave of digitization, a couple of observations which we do at T-Labs, that's the R&D organization of Deutsche Telekom, and we take our input not only from Berlin but also from the Silicon Valley, where we have locations, and from Israel, proudly founded in 2004, and since then collecting insights and producing output. The four things which are the substance to the changes that we see are, number one, the trends towards webification. Browsers become more powerful, and the battle between Google and Microsoft is something which changes all of our worlds. Browsers are so powerful that you can do things with them which you have not been able to do with them before, and I'll come to that. Number two is cloudification. Cloudification is also much more than a word. You can all of a sudden do things which you could not do as easily as before, and we'll come to that as well. Both of these things come with a productivity increase in software generation, and I've left something that is maybe not so obvious for all of us as my last indicator, the virtualization of infrastructure, where you think, you know, everything is fine down in the networks. Not the case. Maybe the biggest revolution is down there in the networks. So off we go. Observation number one. So these are the three layers. Typical technologies which you see behind these trends are Webrtc. So if you don't have that vocabulary, piece of vocabulary in your active vocabulary, take it along. Webrtc is something that leads to capabilities in the browser domain that allows all of a sudden to develop entire communication systems just based on the underlying browser. Number two, OpenStack is a typical technology in the domain of cloud and IT. And number three, another terminology, another interesting term is software-defined networks. And that's what they do. Number one, Webrtc. You have here the first video conference, which has been set up 4 years ago with a single line of code. That's quite a change. And how did that come along? Because in the World Wide Web Consortium, there is a standard emerging that's called Webrtc, and that allows exactly that you trigger an API that allows you to set up a video conference with just one line of code. Does that change the way we produce communication services from now on and in the future? For sure. It has never been so easy to build communication services as now. I'm from Deutsche Telekom. We think about that. It's very, 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 very relevant for us, and you see it already in practice in minor things. But of course, we are working also on this topic in a larger scale. For minor things, you might observe it when you come to the telecom service for the remote diagnosis of what goes on when your router is stuck, and you might be the one who's rooted into this new type of interaction, where that's an ad hoc video conference being set up with the means of Webrtc. That's one of the effects which we see. Just goes without saying. Many of you probably have them in their customer services as well. It's something which you'll be working with as a digital company anyways. If you don't, look into that. Number two, the cloudification example. Does anyone need the cloud? No. Not as such. People have, you know, problems which are hard to actually translate in the first place into an IT problem. Take the port of Hamburg. The port of Hamburg wanted to increase its turnover by the factor of 5 without building new roads. That's the cloud problem. Doesn't really sound like a cloud problem, right? But what they observed is if they want to increase their turnover by a factor of 5, they need to somehow get the containers through the traffic jams in a more smart way, and also to arrange the arrival of ships and everyone else who is active in the port, I don't know that in English, but the Stauer, Festmacher, and all these people in a way that they all play together to do it just in the right time. And for this purpose, you need to know what's in the container, which container needs to have priority, when is the ship arriving, when is the truck ready to go there. And for this, you need to connect the systems who know all this. If you can look into the container via the SAP system, you have the information whether this container needs priority because it needs to be in Wolfsburg at the first one or not. And then you can actually trigger the truck driver to be at a certain point in time. He gets a tablet for this with location-based information. And by linking the systems of the parties in the port, you get a much more efficient flow of logistics. For the port of Hamburg, it translates into a factor of 3. They can increase the turnover by a factor of 3 by linking the systems of the parties in the port. Now, is that a special case? Is that an exception? I don't think so. This is, for me, a blueprint of what goes on everywhere, where you have cloud systems which are easy to connect because they are in the cloud. You don't need to go on premises to connect the systems. And you have this wherever you have logistics on a large scale. What you also observe is that we as large companies, we all go out to think again what this possibility of connecting our systems, the web of systems might bring for us. Be it the logistics case or be it the remote case called Industry 4.0 in a sense. In most cases, it's always about the same thing. A value chain that is being re-engineered with the help and the possibilities of the API situation which we have right now. I would call it a renaissance of re-engineering. It's the renaissance of digital re-engineering which we see there. Currently, the stage which I observe is that all major companies know there is something out there. They're looking for orientation. They gather. Here you see such a gathering on our premises of the large brands. But the actual thing which we all need to do is to identify these core processes, the core value generating processes which we have, and to digitally re-engineer them, one after the other. And we can expect increases of efficiency by a factor of 10, increases of speed with this order of magnitudes. And no one can resist an order of magnitude change, that's for sure. Last but not least, the thing which might not be so obvious, what's going on in the networking part. And this was actually the newspaper clips that totally woke me up for sure. There was a little company in the valley with 50 people, and that sold for 1.3 billion US dollars. So that's definitely worth looking into that, right? How can, and the other piece of information is that these 50 people have just come together as a company 3 years before that. That's amazing. That's amazing. It made me look into that, and here is actually the guy whom we still know from our lab in the Valley as a PhD student, Martin Casado. He has founded the company, so we followed through his trend. And let's see if that thing now works. I have some original footing with me.
Hi everybody, this is Martin Casado from VMware. So a few years ago, we disrupted the server industry through principles of virtualization. And now we're doing the same to the networking industry using software-defined networking and virtualization. So we at VMware believe that decoupling software from hardware will lead to a standard operating system for fixed networks. This paradigm, called software-defined networking, will of course change the operating model of carrier networks. Starting from the data center, network virtualization techniques will move to other areas of provider networks very soon.
And now comes the highlight of this presentation. I will explain to you software-defined networking on one slide. Here we go. You see that? Watch the magenta items, zoop, how they move there. Okay, what has happened? Now this is what we do as telecom operators until now. These are highly integrated, highly developed, highly expensive components, and when you stick them together, you get a network for critical infrastructures. You get a telecommunications network. And you have things like firewalls, you have back-end routers, you have access components, you have controllers in there, and some of these components cost millions of dollars, also millions of euros. It's a lot of money. And the skill of a telecom operator is to connect those pieces in a smart manner. And then comes Moore's law and says, okay, why are these components highly integrated? Why does the software need to be so diligently be tailored to the hardware below it? Because brute force is just more and more easily available. The processing power is growing, so there is no reason actually that the software that controls the hardware is so granularly fine-tailored to the hardware. And then people get the idea and say, okay, let's just use the brute force components, standard components of switches, storage, servers, get them in the most standardized fashion we can do that, and of course buy them much more cheaper. And the control layer, the control software, which was specific for every component before, remember these magenta cubes that went up, the control logic, the spirit of the machines. This is something which we all put together in one big operating network. That's the standard network operating system. That's the thing about here. So what we get is basically something which we've seen in the PC industry, which we've seen in the so-called, in the application space as what we call in the telco industry the over-the-top. I expect that we get something as an over-the-top phenomenon in the networks. So the people who control this networking layer, this operating system of the networks, they are the smart guys. They are the precious guys. They're probably the successful guys. This is why so much money goes into the people who work on these operating systems in the network. And that's why a lot of venture capital also went into the companies that know very well this type of material. If it all goes well, what will we have? What will we have in the future? We will have cheaper networks. We'll also have a situation where it's much easier to connect networks on a global level. All you need to do is to connect the operating systems of the networks on a global level. You don't need to go to the network border and do a lot of modifications there in order to connect to a different network. This technology is currently used in the server-to-server connection by the large internet companies. It's also used in initial trials by the telecom operators. We used that 2 years ago at Deutsche Telekom in one country. That's not as large as Germany, so it's easier to handle, and we learned enough that we know how to apply this in the future rollout of networks. What I expect is that there will definitely be someone like a Microsoft of the networks. It will not be Microsoft, of course, but it will be someone as precious as Microsoft producing this network operating system. What I also expect is that by the ease of being able to connect networks globally, we'll have also a tendency towards more international infrastructures. There are some side effects as well, which I want to show you. Andreas von Bechtolzheim, you know him as the founder of Sun. I was always wondering, what is he doing in this little subcritical company called Arista? He's going after the same thing. He thinks it's an even bigger thing than the Sun microsystem initiative that he did before. Now, side effect number one is, when you can connect across networks, of course you can connect securely into the machinery, into the production machinery that's distributed globally. And that's a big issue. That's a big issue, and the machinery people, they're very, very afraid of connecting things to the internet because of all the unknown threats you buy in for that, and all of a sudden, that's never been a problem when your machine runs still on Windows XP. Now it's a problem because you're connected and you can be attacked. Now, connecting securely is a big issue, but you need to be able to do that globally, and you get this through software-defined networks. You're able to get this much more easily than with standard technology. It's a side effect, and it will also build up to the wave of digitization in the industry, because it works. One of the things which you might have seen at the IT Summit, and now you can put it into context, is that we announced there, between a couple of companies, the setup of the world's largest so far connected testbed, we call it. It's in the context of Industry 4.0. A couple of pre-competitive places are connected, and that's the background. We try to learn how this connection on a larger scale actually works, how secure connection, how SLA ensured connectivity looks like. And when all goes right, this expands definitely on a global level. It has a web page. I want to conclude with actually the confirmation or the insight that a journalist of a major German newspaper had when we had our 10-year anniversary last year at T-Labs. And I hope that I closed this loop with a statement that there are enough substantial indicators, there's enough beef to the hypothesis that yes, in the next 2 to 3 years, there's so much going on that we have a bigger change now in the next few years than we had, probably in the last 2 decades, and maybe also in the time before, because we're going through a phase of redefinition, because it's possible. Thank you for your attention.
Thank you. Wow. We've got plenty of time for questions. If there are any, hands up. Show me. Yes, gentlemen. Riemersberger, do you want the microphone?
Yeah, I'll take it. First of all, lieber Dr. Arnold, great presentation. Who is going to be the winner of the network operating system? What is your prediction?
The brave ones. The brave ones. You put it right to the point, right? And as this stays in the family of the network community, we can openly discuss, right? So the tricky thing is that the people who are in a good situation to move, they are still bound to the expectations of the shareholders. So, would this be a good presentation for Deutsche Telekom's annual shareholder meeting? I'm not so sure. It would probably create more confusion than assertiveness that the right things are going on. And then comes the art piece, right? So you need to continue, of course, your existing business models, as an established player, while doing the greenfield stuff at the same time, the two-handed thing, ambidexterosity, like the innovation researchers call it. So in the car industry, we saw it that BMW does it well, right? They do the classical models and they come with the electric car thing. So I'm happy that Telecom, tries to improve its existing business while working on this thing at the same time. It's good. Question is, do we have too much? Is that too much of a burden, right, for established companies? All the legacy, are we able to move that forward and so on? So there are 2 types of potential winners, right? Either the big internet companies who have it all already between the server infrastructures, so that would qualify Facebook, Microsoft, Google, Amazon as some potential runners-up. And then there are the people who have the customer base and the expectation from the customers and whom you would rather connect to things like just from the brand connotation, you would expect that they are the ones who deliver this type of secure, quality-assured, SLA-based connectivity on a global level. It takes some courage, and that's what it boils down to. You can, I don't know if we have an index for courage already in the leadership. That's probably the one.
Here's another courageous person who would like to ask a question.
Andreas Gördeler from the Ministry for Economic Affairs. Two questions. When will the Deutsche Telekom start with the introduction of this network operating system in Germany? And the other one is, what does this new operating system mean for all the principles we discuss, like net neutrality?
So with introduction times, that's something where I try to keep out as much as possible, because that's a question of resource prioritization and so on. But I can tell you the underlying logic. So this is being done in smaller countries in Europe under the umbrella of PANNet. That's also, I don't know if Claudia Niemert, our board member for technology, spoke about it. PANNet is a thing where we try to do it in other European countries. And at the right point in time, we connect also the German network into this community there. It takes some learnings, and actually the timeline is not as fixed that there would be a clear answer, because some things we will try to insert already in the IP migration, other things you need to do greenfield, and the answer is not 100% clear. Some of the things happen already now in the IP migration. So I could say it's happening now, which is part of the answer, and the other thing is, full-blown, I don't know, full-blown next 10 years, between now and next 10 years. Now, net neutrality. Net neutrality is something which should only be discussed when you have time to go into details, because there are a couple of, it's also about the vocabulary, right? Who likes discrimination? No one likes discrimination, but unfortunately, this word is used as a synonym for quality differentiation. Of course you need a quality differentiation when you do such things. You need it one way or the other. Either you get it as a workaround, people set up content delivery networks. That's nothing else as a quality assured network mechanism. Does that comply to network neutrality? Yes, obviously it does. So quality differentiation, has to be in place. And whether it puts certain players into disadvantage or not can only be answered on a very detailed and very specific exemplaric level in my eyes. Because when you try to solve it in one sentence, it's usually as right as it is wrong. It's usually wrong.
If we can make this one short, I would love to get one lady in, which we haven't had yet. So please, let's collect those two.
Okay, just quickly, Julian Hardenberg, Webrtc. Compared with another industrial revolution, you're basically, as Deutsche Telekom, building railroad tracks as the backbone of this revolution. What is your viewpoint on network stability? And if I do all this you presented, what happens if I lose connection and can't talk to my machines anymore?
Exactly. So what makes me confident is that operators have already lived through one major change already. That's the transition from this electromechanical switching thing, where you have big places which we now use as an innovation center, and it was full of to the digital switching. So it threw a couple of companies out of business, famous German ones, and so on. So as an operator, I think as the user of the technology, we have a better chance to survive the disruption or to take advantage out of it than the suppliers. That's number one. Number two, it's exactly what a good offer needs to promise. It's the reliability, it's the service levels, it's the security. So it must not break off, because when you are in a software update process in a machine that's in Japan, big trouble. You know that from your set-top box. When there's a software update from the network and the connection is lost. Bad situation. You don't want to have this. With a set-top box, okay, maybe you can allow it in 1 out of 100,000 cases. For industrial cases, not possible. With the technology I showed you, it's possible, it's doable. It's doable, it's controllable. You know exactly what happens on the customer premise. You can sense that, and then you can restart. You're in control.
All right, and now the last question.
Elke Kinkel. Thank you very much for your highly interesting talk, Herr Arnold. One question which comes to mind for me is the second wave of digitization. It's very, very international. And where would you see the German competitive position within that? as a representative of Deutsche Telekom or other German companies, where do you see German companies here?
Thank you.
So there's, speaking generally, right? Speaking generally, it is a shift of relevance towards people who know well about operating systems. So we had some at the beginning. So people who either build browsers or operating systems become more important. That's number one. Number two, people who know how to build cheap components, they are also increasing their position. But just imagine the situation of maybe a manufacturer of hydraulics components, a German, producer of hydraulic components that have a very long lifetime. And that's why he sells his components, because people know if I buy this, they are there for 30 years. A cheap manufacturer, his components maybe have a lifetime of 5 years. But he says, I connect those to the internet, and I know exactly when this component fails, and I just send you another one to exchange it. And I'm still, over the lifetime, I'm still 80% cheaper than you are with your 30 years long components. That's an issue. That's a problem. So I see this Chimerica type of thing very, very clearly, as everyone sees here. That's a question, what does it leave for us? For us, it leaves a couple of strengths that are obvious. It's the trustworthiness, the reliability, and so on, which you need to translate into certain aspects which people expect from us, like the security, the reliability, the how to deal in a diligent manner with critical infrastructures. Do we know how a component behaves in the connected manner? We should know that. When something has a German flavor to it, it should be clear that the components there, they come with a certain reliability. Do we have a DIN norm for this? No. Does DIN think about this? Yes, it's good. And so if institutions like DIN, like the BSE, like the companies, they all move into this direction, I think there is, in the same way as it is now, there is something for people who want to be known for reliability, diligence, and longevity, but it needs to be translated. Okay.
And with this, I would call it a wrap. Thank you so much, Dr. Heinrich Arnold.
Pleasure. Danke.